Let's start our lesson here on the relationships between chords and arcs. So what we're looking at here is a circle, and in each circle you have two different chords that are the same distance from the center of that circle. So remember that the distance from any point to any line segment or any line is always the shortest and perpendicular distance. That's why I have the perpendicular marker right there. And so what you have is these two congruent chords, and in a circle that you're going to have two congruent chords, then they must be equidistant from the center right here. If they're congruent, then not only has this little distance, is it perpendicular to this chord, but it also bisects the chord into two congruent pieces. So I could put double marks there, and it's going to be the same thing on the other side. So it's almost like it matches up on each side there of the circle, each chord. And now you have two chords that are congruent, and if the two chords are congruent, then the two arcs that, I guess you could say, intercepts, we used that word before, intercepts that chord, the two arcs there, they're also going to be congruent. And finally, if the two arcs are congruent, then you're going to end up with two. Let's say if I were to try to freehand draw that, two central angles that meet those congruent arcs, then those central angles, then they will also be congruent as well. So what you have is sort of a looping chain reaction here. If you have two congruent chords, then that causes you to have the two congruent arcs, and if you have the two congruent arcs, you're going to have two congruent angles, central angles there, and if you have the two congruent central angles, then you're back to having the two congruent chords. So they all match up in that way. So that is the relationship that I wanted to show you, and now we're just going to practice. Really, they're not too bad here. 3 examples using this information. So let's start with the first example. The first example, I'll move that to the side there, or box that off to the side. The first example is this circle with this information inside of it. So go ahead and draw it with me. There's a chord there. There's my center and this little piece. The best thing I could relate it to was kind of the apothem that we have when we have regular polygons like we did with areas. So you have that piece there. Let's say you found out that this is 24 feet. 24 feet all the way across there. And they are asking you to find 2 things in this picture. First of all, I need to put the letters on here. This is A. This is B. This is circle C. And what they want you to find in this particular thing, I don't know if I have where that came from. Okay. They want you to find the radius. Put a question mark. They want you to find the radius, and they want you to find the measure of arc AB. Okay, so they want you to find the radius, they want you to find the measure of arc AB. So as I begin to work on this, let's change the color now because this was the given problem. I can go ahead and mark off that radius. Oh, I left out one piece of given information. You may be wondering, well, how much is this? It needs to be in there. This is 5 feet, that little piece there that I said I could relate it to the apothem. It is 5 feet. So now let's go ahead back, and we're getting ready to draw in the radius. It's the first thing that we need to find. I'm just going to draw this one over here. I could have drawn CB. That would have been fine, but I just chose to draw this one. If this is 5, remember that AB by this distance from the center is cut directly in half. That makes this little piece 12. All right, so the radius then is the hypotenuse of this right triangle. And it turns out to be one that we don't really have to do Pythagorean theorem to find. You have 5 and 12 for the legs, so this must be a 5, 12. We're missing 13. So AC, which is a radius, is 13 feet. Okay, we figured out one thing. The next thing we'll need to find is the measure of arc AB. Now the measure of arc AB, according to our relationships, this arc AB must be the same as this entire central angle in here if I were to extend the rest of that radius right there. So those are going to be the same. Well, I can do that by using my right triangle trig to find the measure of this angle. Let's go ahead and do that. So if x is this angle right here, I'm going to call that x because that's going to be half of the entire central angle, which will equal the whole arc there. Then I know that the tangent of x will equal 12 over 5. That was one way for me to do it. I could have done something like the cosine of x is 5 over 13 or the sine of x is 12 over 13. Either way, it works for me. I'm going to do the inverse tangent and find out that x is about 67.4. In your calculator, make sure that you do inverse tan to find that. And now I need to double that to find the whole angle. So 2x, when I double that, will give me 134.8. So that is the measure of the arc. Because this whole angle is 134.8, then the whole arc will also be 134.8. Okay, let's go ahead and move on to the other two examples and clear this off. And our second example will be with this circle. There is a chord here. And it meets the center. Okay, I'm kind of rushing on account of time. That's not the most perfect picture, but we'll have all the given information. Remember that what's most important in geometry is this information that we have here. So that's 2. And then this radius, because it goes all the way to the end there, is 3. Okay? And again, we're going to find x as we've done in other types of problems like these. So if I have to find x in this particular circle, I can do that by taking this idea that this is the radius. Then I can ideally like close this door, so to speak. If I close it, then I'll form a right triangle. And this is 3. This radius over here is also 3. So I call it closing the door because it's like I swung this thing shut. And now I have a 2 something 3 type triangle where I have to figure out that piece. And I can do that. So I'll do 3 squared will equal 2 squared plus, I don't know what this is, but let's call it y instead. Y squared. So I have 9 equals 5 plus y squared. And I subtract 5 from both sides. So y squared will equal 5. I did that backwards. Let me erase. I hope you saw my mistake earlier than I did. 2 squared is 4. And then when I subtract 4 from both sides, I get 5. And now y is equal to the square root of 5. So y is that. And if this is y, then x is 2 of those. So y is square root 5. Then x is 2 square root 5 because it's 2 of those. And I found the value of x. Very good. One last problem. I'll go ahead and clear out again. One last problem. Number 3. Finally, let's say we have a circle. And in this circle, we're going to have a diameter that passes, of course, through the center of the circle. We're going to have a chord right here and a radius there. That wasn't meant to kind of go over, but there we have it. And then this is x. What we're looking for, again, we're going to find x. And here's the other information on this picture. Let's say that we know that that chord is 20 units and this arc out here is 86 degrees. And they want us to find x. So here's how we'll go about finding it. First off, x is a part of this this isosceles triangle. I'll draw it like that, where this is x. So this also must be x right there. It's isosceles. We know that this is 20. Right there. And so now I'm going to go about finding x by constructing that altitude there, because that's where I'll get a right triangle to be able to do my work. So this part is 10, this part is 10. This is the x that I need to find, but I can't do it unless I have an angle in here somewhere from trig, and I can get that angle. Let's go through the process of getting that angle. If this is 86 degrees, then this whole piece right here must be 94. Because central angle is going to be the same, so that's 86, so this is 94. 94 plus 86 will equal a total of 180. And if this is 94, then this little piece here must be 47. All right, so let me just quickly do that. So 360, actually, we don't need 360. We could actually do 180 minus 86 is 94, right? Because this whole thing is 180. 180 all the way across. Minus the 86 gives you 94 in there. And then this whole thing was the 94. So if we cut that in half, this piece is 47. And so now I can figure out this hypotenuse of this little one right here to find my x. So I have an opposite side and a hypotenuse. So this will then be the sine of 47 will equal 10 over x. And we know we solve this by division. And we find that the value of x is 13.7. So that is the length of that radius. All right, I know I've gone a little bit over my time, but I hope that you understand that, and feel free to stop and go back if there's something that's confusing to you. Let me know in class so that we can discuss it. All right, see you later.